1, 2. Now it's on. One, two. Can everyone hear me? Can we hear me up the back? Maybe not. All right, I'm going to get started, everyone. So if you can settle down and I'll get going. We've probably got more slides to get through today than I actually have time to talk about. So some bits I'm going to squish through and other bits I will cover again in a later lecture. But I should get started anyway. So if I could just grab everyone's attention so I can get going. So we're into week 3 now, which means probably some people are starting to get the hang of the basics and sort of thinking, okay, so sometimes when you do this, this kind of thing happens, and sometimes when we type other kinds of words in our programs, different things happen. Don't worry too much if it's not clicking yet. The analogy I like to use the most, and I think a lot of people sort of understand this one reasonably well, is like if you learn a new language or something like that, it does take more than a couple of weeks before you're actually speaking it or anything like that. So if you're constantly having to go back to the notes, having to look at the lecture slides to decide exactly how you're going to do something, don't worry about that. That makes sense at this point. It takes a while before fluency sort of kicks in, and you know, you can go for years and still be thinking, wow, that's something new. I didn't really know how to do that properly and stuff. So don't worry if it's a process where we slowly build up our capability to code, and it'll be fine if it's not quite there yet and you're working on it still. Okay, so what did we look at last week? This is just the stuff that we sort of added last week. We didn't, we kind of went back over all of the first week's content as well in our last week. So we looked at branching code. From the very beginning, we were looking at how to store things in memory, so how to use variables, and also how to communicate with the user who might be using our program, either taking input in with something like scanf or printing something out with printf. So you can always go back over that stuff if you're wanting a refresher on it. We're not going to stop using any of those things, so you're not going to stop getting practice on them. We're going to continue using stuff like input and output all the way through the course. We talked about problem solving, which I think is one of the kind of fundamentals. This course is called the Fundamentals of Programming, or Programming Fundamentals, right? So there's a lot of things like that, which is like, okay, how do we need to think if we want to get our computers to do some of the thinking for us? And so it takes a little bit of preparation, and it takes a little bit of bouncing around between ideas, and the ability to sort of go through and say, okay, what works and what doesn't, and how are we going to make that work? So problem solving is really based on that kind of perspective on how you want to make things happen in a computer. We also looked at while loops. So this was, as opposed to the branching code of the if statements, this was repetitive code. So our ability to do things more than once. So we only have to write one piece of code, and we can run that any number of times. And as you saw from some of the examples, you can run it an infinite number of times, or you can run a specific number of times. Today, we're piling a few things in, although the first two are reasonably related. We're going to talk a bit today, at least the first half, even more than the first half of the lecture, on the idea of writing code for humans. So there's a lot that goes into making sure that we ourselves understand our own code and other people can understand our own code. There's an interesting kind of, it's not really a statistic, it's sort of more of an anecdote about what it's like to be a professional programmer, is we actually spend something like maybe 15% of our time writing code. So we've spent about 15% of our time making new programs or implementing things that we haven't seen before and stuff, you know, building up those while loops and if statements and stuff into something that can potentially do something. And then we spend 85% of our time trying to figure out why it didn't work and getting it to actually do the thing that we want it to do. And it's really funny because, like, you think that hopefully that's going to change, like, because you're probably in that state right now, right? Where you do a lab exercise and you like spend 5 minutes, you go, okay, this is all the code, and then it doesn't work, and you go back and you go back and you do it again and again and again, trying to get it to work. It doesn't go away. That's still what it's like when I code. The only difference is the things that you're expected to do with your 15 and 85% are just harder. So when I was working on my PhD, I think that the code that I was actually using in my PhD, I wrote in like 1 month, and I spent 2 years fiddling around with it, trying to get it to actually do what it was supposed to do. Never really did either. Anyway, so what we can try to do at least is make sure that in that time where we're trying to fix things, in that time where we're trying to turn things around and make things work better, how do we actually make it so that we can genuinely understand what we're doing in that 85% of the time? And that means we're going to write our code so that we can remember it more easily, and we can write our code so that other people can use it as well. That's another thing about it, is you're never really going to be working alone. It's one of the strange things about university is we do a lot of individual assessments, and we kind of do them because we need to give everyone a mark, right? So everyone needs to be able to get some feedback at the end of the course saying, okay, this is how well you understand it, and this is how much you might need to work on this if you want to continue, or this is how much you can be happy about what you've done so far, you know? So if we get into the idea that we're always going to be working with other people, we want to be able to hand our code over to someone else and they'll be able to use it. And we do that by following a lot of conventions. You know, we do that by saying we're going to agree to work the same way on something, or we're going to write our code so that regardless of how well the computer understands it, because the computer can understand all kinds of sort of messy gibberish in code, regardless of how that happens, how we decide to put together our code can be incredibly important, because if you pass your code off to someone else, they don't understand it, they make modifications, they change something they shouldn't have, things can get really messy. Another thing we're going to look at today are code reviews. Code reviews are one of the methods we use to not only do teamwork, but also get a lot of information from our coding. That's where we actually look at other people's code, and we have a discussion about the code itself. And we talk about what is and isn't working in our own code and other people's code. And it's probably one of the best ways to learn about code. We've actually been doing it quite informally already. Anyone who's had a Monday tutorial has probably already seen one, because your tutor would have done a quick code review at the start of the tutorial. But I'll talk about what they are as we go along. The other thing I'm going to try to squeeze in at the end today, and it depends on how much time I have, how complete this will be, we're going to look at functions as well. So functions are another code construct, and they're our way of sort of separating our code for a little bit of reuse of code, and they help a little bit in terms of readability as well, by us being able to sort of package our code into different places. I'll explain that when we get to it. I'll go through the actual details. Okay, so a little recap of what we were doing last week, because one of the main points that we were looking at last week was while loops. And while loops was the ability to run code more than once. So when we're using a while loop, we have something that we test. And if we think about it the same way we think about the if statements, it's a question and answer sort of thing. Actually, I'm going to skip through the slides that actually have code in them. So here is a while loop, and this is one of the particular. So I showed you two particular ways of using these that were going to be the most commonly used, the way that you're expecting to use them most of the time. This one is, I want to run this thing an exact number of times. And if I want to run something an exact number of times, I can set up a number. Here I'm using I. I is actually a variable that we use a fair bit in looping, and I used counter, I think, last week. A lot of people shorthand it down to I, and the I is usually short for the word iterator. You don't really have to know that, but often if you see loops with I's, you'll know that that's the number that's going to just sort of increment, as I was saying before, just go up by 1 each time we go through the loop. So the main parts of this construct here are the keyword while, the question, and the answer. So the question here in the normal brackets says, how far am I going to go before I'm going to stop? And then inside here is whatever I'm going to do in there. So this loop doesn't even have anything particular that it does inside there, but it has the incrementer in there, which is the I equals I plus 1, which says that every time we run the loop, I goes up by 1. And that means we're going to run it exactly 10 times. And the values of I probably should put some comments in here. Sometimes we like to put comments in here about what's actually going on each time we run the loop. So we know that each time we run the loop, I changes value. So every time we run the loop, we know that the loop has run before a certain number of times, and that's going to be I. And then when we finish the loop, we know that I is going to equal exactly the same as that number there that we tested it on. The other way that we were thinking about stopping the loops, and I should actually go back to that previous slide and say it is important to remember that every loop that we start must have some way of stopping. If we make loops without knowing how they're going to stop, then we don't know how our program is going to continue past the loop. As we saw with the hilarious rickrolling last week, that if you have a loop that never stops, then you have a program that can't finish properly, or a program that can't even continue to the next parts of what it's supposed to do. So the other way that we might stop is we might stop by exiting based on a certain condition. So this can be, I mean, technically this one's exiting on a certain condition as well, but it's a very, very controlled condition where we're saying this is at exactly the number of times that I is going to change, and then we will exit. But sometimes we might go on a different loop where we say we just have this integer variable here called end loop that says are we or aren't we going to end the loop at a certain point, and certain conditions can change that loop or not. So this loop could potentially run forever. It could just keep going because maybe my user just never types in an odd number in this case. So this is like if it's even, it keeps going. If it's odd, we switch end loop to 1. Switching end loop to 1 makes this condition here fail, and then we exit the loop. So if we hit this condition, we exit, but if we don't hit the condition, we'll keep going. So we don't know before this thing runs exactly how many times it's going to run, but just if it finds the right condition, it will exit. So we're going to use these loops a lot as well, and if you want to, you can just kind of memorize these two different ways of using while loops, and that will be most of the things that you can do with them. All right. So I want to talk about writing code for humans. So we call this code style, and you may have noticed on the course website there's something called a style guide there. Every organization has a style guide, and the style guide just says this is how we write code within this organization. I haven't looked that closely at the style guides in the sort of major hirers of CSE graduates and things like that, but I know that they're going to be reasonably similar to ours. So there's a lot of things that are going to be placed at the same level of importance in places you might work at or places you might do research at and things like that. So we're going to talk about some of those things, but I want to talk about like why we want style, why we want good style. So I mentioned this a little bit earlier, is that if we're going to spend a lot of our time trying to figure out why our code isn't working, we want to make sure that we have a really, really good understanding of that code. So one of the things that we're going to need is the ability to go back over our own code and see whether it actually makes sense to us or not. The interesting thing is it's a small kind of investment in the amount of time that you spend doing things. Because, you know, if you're just hammering out code, you might think, I don't need to indent that. The computer's going to be fine with it. It's going to understand it. And you don't realize that that little amount of time saving that you might put in at a certain point might end up costing you a whole lot more later when you don't realize whether something is actually inside or outside a particular loop, or you don't realize which brackets are open and closed at which point in time. So I get that a lot, right? You get that where you finish something and you go, this is going to work, and then you compile it and the error is in this weird place, or the error is something that you don't understand at all. Sometimes that's just the fact that because you didn't line up your brackets, you can't see which ones are open or closed, and then you just don't know when the program's supposed to end. I'm going to talk about the specifics as well, actually. So what are some of the things that we see most commonly in style guides, and some of the things that we think are the most important in terms of what we do and don't understand about code? So Indentation and bracketing is one of them, definitely. So that's something where if we can't see where we are at the present time, so if we're looking through our code and going, okay, this line runs, then this line runs, then this line runs, if we can't see whether we're inside an if statement or outside an if statement, inside a while loop or outside, it's really hard to actually tell where you are and understand what the code's meant to be doing in that point in time. We've got names of variables and functions. We haven't made any functions yet, but we're going to be making functions, and they're going to be a little bit similar to variables in that we're going to give them a human readable name. So at the moment, we're just thinking about variables. If we describe what our variable is there for, so we describe its reason for its existence and what it might do in its name, then we're going to get a lot more out of it because it's going to be less confusing to us later when we start to use it. Repetition of code is something as well. So I looked at this a little bit when I was talking about while loops, where I just copy-pasted the same code 10 times. I don't know if it was 10 times, but it was a lot of times. And if we repeat the same code over and over again, what we're going to get out of that sometimes is that if we need to change the code, we have to change it multiple times. We can't be sure that all the duplicates of the code are actually the same and are actually working together. So we need to be pretty careful of those things. We can use things like while loops, definitely, to avoid writing the same code more than once. And anyway, you don't want to have to write the same code more than once. All right, that's super annoying. So trying not to repeat code is good. We're okay if the computer has to repeat execution of code multiple times. That's fine. Computers don't tend to get bored. I don't know, some computers might get bored. I don't know how self-aware the computers are these days. Anyway, we, however, don't want to write the same thing more than once because it's unnecessary, it's also boring, and it leads to mistakes. So as much as we can avoid repetition, we try to. Clear comments. So knowing how much to write in the comments, where to put comments, and what comments are going to be useful is something that's really handy. So often it's a matter of seeing chunks of code that are on a particular subject or topic. We could nearly paragraph that and how we're going to put a comment explaining what that is. When we're talking about what's inside and outside of brackets, putting comments in to say, okay, this is where we're up to at this point. This is what we know about what's happening inside our loop at this point. Those comments are really handy as well. Consistency as well. So we could follow the style guide perfectly for, say, half of the code we're writing, and the other half of the code we could follow a different style guide, and then we could confuse the hell out of people. Because suddenly the brackets are in a different position. Because there are different bracketing conventions with different style as well. And if you switch between them, people are going to get really confused. So what we usually say is, wherever you're working, wherever you're doing your code, there's going to be a style that that institution or that company or whatever uses. And what we're going to do is, as much as we can, we adhere to whatever that group is doing, because that way, if we put our code in amongst their code, anyone who's reading it is not necessarily going to be able to tell the difference between different people's code and be able to read it all reasonably easily. So again, the idea is the easier it is to read, the less mistakes we're going to make. So let's have a look at some code style that did not entirely work properly. I'm going to open VLab. I think I haven't saved this one in advance, so I'll just have to download it. That's our course website. It's taking a little while getting there. I wonder why that's taking so long. All right, while that's happening, I'll start some other stuff. So what have we got here? Just ls to see where I am. I'm going to go into my COMP1511 directory. And I haven't made a lecture 5 directory yet, so I'm going to do make directory lecture 5. And if I do a ls there, I can see I've now got a lecture 5 directory. And now this is loading fine. You can see a lot of random stuff here that you don't need to worry about. Okay, so this is the one that I'm looking for here. I've got some code that I wrote in advance. And I'm going to grab that. Is this because everyone in this room is also accessing the same web page? I should have downloaded it before I got here. Maybe we go straight for the download link. This is super awkward. Considering that the website is being hosted here on campus, this should be a lot quicker than this. There we go. I'm going to navigate to my lecture 5 directory and save it in there. Okay. That should be fine now. Okay, let's go to my lecture 5 directory. Okay. I've got a file there called codestylebad.c. So this has been intentionally written to show you what it's like to try to read something that isn't laid out correctly or isn't styled correctly. So let's open gedit for codestylebad.c and we have a look at this. Okay, so this is one that I made about a year ago. I was teaching this same course about a year ago. And if you look at some of this stuff, okay, that is the whole program. Okay, that's the whole program. All right, so I'm getting some interesting responses from everyone looking at this right now. It's nice to see that some people are laughing at this because if you look at it, you just go, I don't know what's going on here. So it's an extreme example. But this is an example of code that actually potentially could be very familiar to you, but it's still not understandable in its current state. So this is, I don't think it's exactly functionally identical. It's not exactly the same as the dice checker code, but it is nearly exactly the same as the dice checker code that we did at the start of week 2. Wait, was that week 2 or week 1? It was potentially week 1. It was the end of week 1, I think, we did this code. Oh, no. Yeah, it was the second lecture. So this is the same code that I explained to you at the beginning, but if I'd explained it to you and wrote it like this, then maybe none of you would be here now, because you'd be like, I have no idea what code is or how it works. So just giving you a chance to sort of look at what's going on there, you can probably see multiple places where I've broken my own style guide here. But what's more important than whether I've broken the style guide or not is whether you can actually understand what's happening or not. So if you look at this and you try to read it and you try to say, okay, what's actually going on? There's a lot of issues in here. Actually, does anyone want to, actually, let me see, I've got potential, I can't remember what my next slide is. Oh yeah, I think I've got one more slide. Okay. So obviously the first reaction was, that's a huge mess. And this is something that I think this is advice that I want to give to everyone in general for how you want to think about working in general is when you look at something and you say, this is a huge mess. The first instinct is to think, I'm not going to work with this. This is just horrendous. I mean, people have said that about code like this when you're working in a professional situation. You can just say, look, we can't work with this. We need to make this readable before we can do anything with it. But the trick is, with every problem that seems huge like this, every problem that seems like there are so many things wrong with this, I don't know where to start, the important thing is that we do start. The important thing is we pick out what it is exactly that is wrong with this, and we go through systematically and we say, okay, these are the things we need to fix. So I put it to you now, does anyone have anything that they think is particularly... Oh, another thing, there's an Easter egg in here. This code has an error in it, a really obvious error for it not working the way that the dice checker does work. And you'll notice that you can't see it, and you probably won't be able to see where exactly this is going wrong until we start cleaning it up. I don't have like ages to clean this up, so we're not going to clean up the whole thing, but we'll clean up some of it. So, anyone would like to put up their hand and say something that they think could be done differently in this code to make it more readable? I think we had a hand go up there immediately.
The comments aren't very helpful at all.
Yes. So the comments are not very helpful here. And so I put one in here, which is a real comment that I saw in someone's production code. I'm not going to say which major company that they were working in when I saw this. But there's a comment here. No, I've literally seen this comment in someone's code before, so don't be like this. I can't remember why, but don't delete this next line. So that doesn't help us at all. I mean, sure, it helps us to not delete a random line of code, but why would we do that anyway? What we would love to have here is an explanation of what was actually going on the next line. And that's super confusing as well because the next line has so much stuff happening on it that I'm not even sure what's going on. Also, this one here. Well, I mean, technically it's accurate, right? We're doing something with dice here, but that's not what we're doing with the dice. I mean, I was about to say if we look at this, we can maybe figure out what it does, but that line's pretty confusing as well. I'm not getting a great deal out of this next line. Is anyone willing to offer other ways that we might want to clean up this? Yeah. Yep.
The indentation is a bit horrifying.
Yes. So the suggestion where there was the indentation is a bit horrifying, and I agree. We can't tell which things are at the same level of the program as other things. So for example here we've got a printf. That's 3 spaces. We like to use 4 spaces, so I'm going to fix that to 4 spaces. This one has just extra spaces for no particular reason. So if I start lining these things up, we might start getting an understanding of what's happening. This is inside that if statement, I think. That's also inside that if statement. This if statement should be outside the previous one, and this is inside. Okay, as I start doing that, you start to see, okay, some things are inside if statements, some things are outside if statements, some things return to the original flow of the program. I'm not even sure if that's right or not, because some of these lines are so long, they're going off to a point where I'm not really looking at them. Does anyone else, I'm just giving away another one. Does anyone see another problem? Yep. Spacing. So the spacing is really awkward depending on where I am. Actually, the line I'm on right now is a really good example of spacing. So I've got, what's %x? You know, it looks like a symbol called %x, and it looks like I'm doing something weird with a special character. But in reality, I'm not. It's just a mod x. And so we've seen this before when I was saying we could mod one number into another, and that would force it down into a particular range of our die rolls. And this symbol here that looks like a double equals, it's really confusing if you don't put spaces between like mathematical operators and stuff like that. So if you don't have those spaces, that stuff reads like a jumble of symbols. But if we have spaces between them, it's really much clearer for us to read. Oh, A is a variable. Double equals is an operator, and then 0 is the other number there. So having that space gives us more intuition as to which things are separated and which things aren't. There was another one there, I think you were saying here.
I was just going to say, like, some things, there's more than one thing on the same line.
Yeah. Yeah. So the issue here is that there's more than one thing on the same line, and that's super, super confusing. Right? So just looking at this code from the top down here, the way that we often read code is we just sort of do it vertically. We just go line by line by line. So I look at this and I say, there's an integer. Oh wait, that's a whole bunch of integers. I didn't even notice because they were in such a messy way of kind of being laid out. We can do this. This is even still messy. You know what I'm going to do is I'm just going to give each of these their own line. Like, at least, I mean, we can actually, there's other ways of doing this. We can do it this way. If I wanted to declare all those integers on the same line, I could declare them all on the same line like that. Or if I want to, I can declare them separately like this. It's not super important either way. But when I get down to these lines here, I see these printfs, and I think the only thing that's happening here is a printf. Because what's happened is, a little further along in this line, there is another instruction here. There's a scanf happening as well. But it's really, really easy to miss a second instruction on a line because we like to just scan downwards and we can see this, then this, then this, then this. If someone ever did like a dot point list of things, like the dot points that I put in the lecture slides, and I had a point, and then I put another dot point halfway along that line and a separate point, you're going to miss that, right? It's not easy to read. So what we like to have is each line does one thing. So each line has its one thing that it does, and it makes it really easy for us to go, on this line, this thing happens. And then we go to the next line if something else happens. So we didn't want those printfs and scanfs to be in the same place. So we're getting a bit of information here about what kind of things are happening. We've got another idea here.
Braces missing on the if statements.
There's braces missing on the if statements. So what we might want to do is line up these brackets properly. So the way that we like to do this is, if I open a bracket, so this bracket here opens. gedit's kind of nice to us here, is it highlights the bracket that closes this. So it just scans through our code looking for where the bracket's going to close, and it says, okay, that one there is going to close it. Again, the idea that we often read our code vertically, line by line by line, means that if we close the bracket directly below the thing that opened it. So this if statement was indented a certain level because it was inside the main. The bracket that closes it will be at the same indentation as the thing that opened it. So if I want to see if I have nested, if I have an if inside an if and a while inside that, I can look at the brackets and I can say, okay, this section is that if. This section inside it is the while loop, or whatever it was is inside the other if. And so if I read it vertically, it's really easy for me to see where this bit of code starts and ends. So I can see the entirety of the if statement in terms of its structure because I've lined up the brackets. And if you look at this one here, it's actually reasonably hard to see where this ends. I mean, there is a closing bracket here, but this line's also pretty long, so I'm not even sure whether there's a closing bracket somewhere else. You know, and if someone's not following the convention, it's really hard to see where you are in the code. So I can move this one here as well. Can anyone see anything else that might be an issue? I've got an idea over there, yep. Yes, the naming of the variables. So I have 4 variables, int x, a, b, and y. So we have to try to actually figure out what each of these variables is doing. So if I was to see there's x up here, and I look down here somewhere and I go, there's an x there, I have no idea whether that is the right x, whether it's in the right place, or what even it's supposed to be doing, because I didn't name it in a way that I could understand. So if I look at it carefully, int x, this bit of code here is saying I'm entering how many sides are on the first die, or how many sides are on the dice at all. So this was a way of doing it where we could actually type in the number of dice of the sides. And so that appears to be x, which means that if I was going to input how many sides the dice had here, then maybe a better variable name for this would be something like dice size. And now I'm going to need to go through and replace my x's. So I'm going to do this using a global replace thing. I'm going to press Control H here for this, but you don't have to do that. You can do that up in the edit menu as well. And I'm going to take all the x's and replace them with my new variable named dice size and see how we go with that. Okay, so I've done that replace. And now instantly a lot of my code is reading in a slightly easier way. So I can see dice size is being used in this place. So I can say if A is greater than dice size here. So I can see something that makes sense. That's actually pretty good. Can anyone see anything else that is odd about this code or something that you think you might want to fix? Oh, we've got, sorry, there's one up here. I think the hand went up first, but that is correct as well. I'll talk about that in a second. Sorry, what was it? The paragraphing. Yeah, so everything is just smushed together here. So I can't even tell if things are for a different purpose. So for example, I've got code at the beginning here which is grabbing user input from the user and just storing it in some variables. So I could, if I want to, separate some of these things out. And maybe here's where I want to have a comment and say I'm taking input. Oh yeah, that's another thing is the comments, as we saw already, were bad. So we want to actually put some comments here that make sense. We had to make some sense of the code before we could even start doing that here. So take input from the user about dice size and the values of the two dice. Okay, I mean, I can only see a scan for the first die here, so there's something else going on in this bit. I'm going to assume that this bit was the checking bit, was checking for valid or invalid input. So what we can do now, if our code is written like this, is when we're looking for a particular section that does a certain thing, we can just look for the comments that say, okay, this section does this, and then we know we've got a paragraph of code that says this does this. It's going to be easier for us to read it. It's going to be easier for us to narrow down the bits of code we're trying to do. The other thing we had over there was constant. I have defined a constant here, and I've just called it constant. So that's a difficult thing to work with because anything that we hash define is a constant. So I've given a variable name to something which is 100% correct in that it is a constant, but I could name any hash define there constant as well. So this name's not helping us because it doesn't mean much. And the other thing is it's not identifying itself as something that can't change. So if I wanted to identify this as something that can't change, it should be in all capitals. So this is a convention that just makes it easier to read. I'm going to do a replace on this one. And I know that knowing this program, I know that this is the target value. If I didn't know that, I'd probably have to go through this code and figure out what it was even doing. I don't even know what this thing is doing at this point. But I know that this thing was the target value. So if I replace that all through my code, I can now see that the target value is being used down here somewhere and here. We haven't cleaned up that code yet, so it's hard to see. Another question?
Yeah. You see how you replaced X with the dice size?
Yep.
So you replaced X even in the comments. So I saw the word example and then you made it E dice example at the top. All the way to the top. Yeah, look at that.
So here,
Yeah.
so this is something we have to be very, very careful with. So what I did there when I did the Control H and I did the global replace, there was a point where I should have ticked a box there saying whole word only, because what I've done is I've accidentally replaced everywhere there's an X, which means if I had any other variable names with the letter X in them, they would get replaced as well. So that could have been catastrophic and messy. Anyway, there are a lot of the little things that we can do, and I have slides for all of this. Okay, here's a shopping list of specific issues that are in. We didn't even get all of these. Right, because we don't really have time to go through this entire program and clean it up entirely. But we definitely did look at the blank line separating things. We didn't look at the header comment. The header comment says nothing about what this code does. If I go back to it. You're right. I did the X thing there as well. And here. Yeah, so that was actually potentially a hugely dangerous global replace I did there. You've got to be careful with those. Okay, so that header comment, yes, it does say who I am and when I first created this, but it doesn't say anything about the purpose of the program. And so it doesn't say anything about why this thing exists or what it does, which means that if someone wants a little TLDR, people know that term, right? TLDR means too long didn't read. So if you don't want to read all the code to see what this thing is capable of, if you just want someone to tell you what it does, you expect that to be in that header comment there. And we didn't have any of that information, which means this code's just super annoying to have to use. Okay, we had multiple expressions in the same line. We covered that one. We had, sorry, that was someone else. We had inconsistent indenting. We'd covered that one. Inconsistent spacing, I think that was someone over there. Variable names that don't make sense, comments that don't mean anything was over there. Inconsistent bracketing of if statements, we looked at that. The bracketing wasn't indented correctly, we fixed that at the same time. We didn't see a couple of other things. The inconsistent structure of identical code blocks. So we had checking of two dice, and if you look closely at it, the checking of the two dice I think was done in completely different ways. So we've got this one here, and then we've got another one here, which had an OR in it. So if we were to clean this up, I'm just going to really quickly. There's a printf there. Change that indenting. It's hard to see because we'd have to spend more time cleaning this up. But these two pieces of code do roughly the same thing, but not exactly the same thing. And they're meant to do really, really similar jobs. The same kind of thing on two different input variables. Having things that look very different but are actually very similar makes it very, very difficult. If I was wanting to change the way we were checking the dice, then I would have to really think carefully about what both of these things are doing and how they're doing it. If I'd made them both consistent and look the same, then I'll remember more easily that they are the same. Okay, so we don't have time to go through everything. Oh, has anyone spotted the Easter egg? Oh, we got an idea there?
Is it
Line
line 34?
34.
Because, like, above you say A is less than 1, A is greater than dice size, but really in line 34 it should be saying B.
Yep, you got it. So I'm very surprised that anyone got that because we didn't fix those variables. If you look really carefully, there is a variable for the first die, and that is A. Because we read the value of the first die into A, and then here we read the value of the second die into B, but the checking for valid input checks A again here. So that is actually, you know, you're the first person who's ever picked that up immediately. So, yeah. That's pretty awesome, because I'm imagining that most people here couldn't see that because the variable names are so bad that you can't see it. However, let me change one thing here, and this will show to everyone much more clearly that we can pick up this error. So if I go, I'm going to match entire word only this time so that I don't cause problems. And I'm going to say A is now die 1. Okay, so this should be a little bit more obvious here that I'm doing a scanf for the second die, and it's going into the variable B, and then I'm checking die 1 again. And so now you can see everyone should be able to pick up on this a little bit more easily now if the variables are named correctly. So that was a little Easter egg I threw in there for the fun of it. Okay. So some advice so that you don't end up in that situation with the code that looks like that, and then you need like 1 out of 700 people to be able to pick up where your mistake is. We can pick up our mistakes much more easily if we keep our house clean. So this is the same as cleaning up your room. So who gets into those situations where you have to clean up your room and it's hellish by that point? You know, there's just stuff everywhere and you have to clean it up and it takes you a whole week in between other things to actually clean up your room. Does anyone get into that situation? Because I totally get into that situation. Just funny, I'm supposed to be teaching you the better way of doing things. Having said that, if I was to do a little cleanup every couple of days, so every 2-3 days I clean up the few little things I've been working on, then stuff remains clean. It's actually much easier to keep things clean than it is to do a major cleanup at the end. So what I'm trying to say is don't write all of your code and at the very end of it go, oh, now I need to do the code style thing, and then do it in a separate kind of process where you clean it up afterwards. That's not going to help you at all, because the whole time you're working your code, you're not going to be able to read it. So what I'm hoping everyone does is just put small amounts of effort in all the time as you're making your code to write it nicely, and then it'll be much easier in the end to use everything. So some of the things that are going to be necessary. One nice thing you can do is write your comments before your code, because then you've thought about all your ideas, your problem solving in advance, and then after that you just translate your comments into code. Name your variables before you use them. I mean, it's kind of hard not to, because when you declare it, you have to give it a name, but try to give it the name that you expect you want to do something with it. So a description of what it's going to do, description of what it represents before you start using it. Every opening bracket, everything inside gets indented by 4 spaces, and you line up your closing brackets vertically with the thing that opened it. 1 expression per line, we've seen that already, and we've seen the confusions that can come from trying to put more than 1 expression on a line. And spacing. So these are the simple things that you can just always do as you're writing your code. I've got some slides about them here. So the comments before code is something that can work reasonably well in that I can do this set of if statements here. So this is a slight expansion on the actual dice checker we did, where we've got a success, a tie, and a failure. And what I can do is I can say, all right, I've got 3 separate cases, and I know only one of these is going to happen. But what I'm going to do is just write in English, because I'm less likely to get English wrong. I mean, like, everyone here may have a different native language, but when we're coding in a particular organization that has one language it uses, we try to keep to the language that it's using. So here we're going to use English because UNSW is an English language institution. So I'm going to say this is what this paragraph does, and this is what each of these things inside do. And you note that this isn't even functional code here. I haven't put anything in the if statements, in the expressions that we're checking in the if statements, nor have I put any code inside the curly brackets either. Yet when it comes down to this, it's really, really easy for me to then fill this out with code because my ideas are in there in advance. And also, I don't have to do this double thinking thing. So sometimes you have to think about what problem you're trying to solve, how you're trying to solve it. And the other part of your brain is trying to figure out, how do I translate this stuff into low-level code? If we can separate those 2 ways of thinking, it's much easier to program. Naming variables. I mean, I have covered this a little bit before, but things to remember. Variable names are entirely for humans. Your computer doesn't care what your variable names are, so they're entirely for you to do whatever you need to do with them. Nice ways to tell whether your variable names are working or not is to think about someone else. So, for example, you're working with a lab partner, you think, would my lab partner get it if I name this variable this? So is this something that they would understand? I'm not saying is this a joke that we share or anything, but like, is this something that we actually understand works in a particular way? The other thing that's nice, does it distinguish itself from other variables? So if we had a while loop inside a while loop, and we had counter 1 and counter 2, they don't really distinguish themselves from each other that well. So if we had an explanation for what each one was, that might be nicer. So I think we had the die values last time when we were going through and doing the dice statistics. I'm not even sure if my variable names are that great on that. You can always go back and have a look. And if you want to suggest edits to my variable names, that's pretty handy as well. We're going to talk about that after the break, actually. Indentation. I think that we've seen a bit of indentation now, so you can probably understand what I'm doing here. There's a curly bracket opening here. The curly bracket opening means I go 4 spaces in. If you're using gedit, you can tab, and that will give you 4 spaces. And there's an if statement here that opens the curly brackets. It's also indented inwards. And then we can really see clearly what's inside what. The closing bracket is always indented at the same level as the thing that opened it. If we keep up with this, we can see structure of things really easily. 1 expression per line. So I've got an example of what not to do and an example of what to do here. We're trying to do too much on each of these lines. The more we would squeeze into a single line, the more likelihood it is we're going to forget the thing that's happening further along in that line. So this is about whether we can actually see things clearly or not. So if we put too many things on a line here, we can put them on their own individual lines here, and then we can scan vertically down something and read it. It means it's much easier to read. Spacing, we did discuss this when we were editing things. This area here makes it very, very difficult for us to tell different, actually different objects apart. So each of these things is an individual object, whether they're a variable or an operator or something, and it's much easier to see them as separate pieces for us to be able to read if we put space between them. So there's a bit of white space between each variable and each operator and each value that we put in here. Makes it easier for us to look at. Because here, it's hard to tell what's attached to what. It nearly looks like this B and B is inside a tag here, like an HTML tag or something, and I don't know what's going on. Okay, so if you need more information about coding style, we do have a style guide on the course webpage. Don't worry too much about a lot of the stuff in the style guide that talks about things I haven't explained to you yet. So there's definitely going to be keywords in there that I haven't talked about. There's going to be things like functions, arrays, linked lists, all this kind of stuff. We are going to cover that later. So don't worry about the coding style there. But if you want to look at what the coding style ought to be for these simple things like indentation and variable names and things, you can always look up the style guide. We also have 1511 style, which I think has already been put in a lot of your lab exercises. Has anyone used, hands up if you've used 1511 style. Okay, cool, good. I'm glad everyone's been doing that, because in the lab exercises, we try to do that because 1511 style is okay. It's not great, but it's okay. So it's as much as we could put into like a small program that could read your code and look for the obvious things that you might need to fix in terms of style. So 1511 style is really helpful for indenting and things. It's reasonably helpful for white space. It's not that helpful for variable names, right? Because 1511 style can't read your variable name and say, you used, I don't know, die 3 when there are only 2 dice or something, right? 1511 style is not an AI or anything. It's just a little program. So it can't tell stuff to that level, but it can help you a little bit with the basics. We are going to have coding marks in the assignments. The first assignment is going to release hopefully on Sunday. I mean, I always like to say that it's going to release exactly on a particular day, but the funny thing that you don't realize is, you know, when people pull all-nighters to like finish assignments and stuff like that, I mean, you're on first year, so you may not have done that yet, except maybe you're doing it all through high school, I don't know. We do the same thing when we're preparing the assignment. So at the moment, there's a whole lot of work going on behind the scenes to try to make sure this assignment is working correctly and doesn't have any errors in it before we release it to you. But we're expecting it to come out on Sunday. We're going to have some minimal style marks in the exam as well, so we will need to be able to write things at a basic style level in the exam. We've got a question there. Yeah, so the question here was, is the submission of the assignment similar to the submission of the lab exercises? Yeah, it's exactly the same system. The only thing that we're doing, which is a little bit more, is that we're doing sort of rolling backups on your assignment as well, just in case anything happens to it. So every time you submit, we save a copy of it that you can reuse. I will talk more about assignments later. We're going to release the assignment, and then I'm going to do a live stream on that just introduces the whole assignment and gives you hints on how to get started and stuff like that. You don't have to be at the live streams, especially because our tutes go all the way through the week. So me finding a time that someone isn't in a tutorial is very difficult. So you can take part in the live stream if you want to. If not, obviously it's all recorded and then you can just check it out later if you need. So you can treat it like a live stream or like a video, up to you. Okay, so I think that takes us to the break. I see some people know this meme. And I just want to point out that code style is not just about making it look pretty, like that. But it's about making it reusable. It's about speeding up our development time by making sure we can find errors easily. So it's 10 now. We'll come back at 10:05. I'm going to talk about code reviews, and I'm going to talk a little bit about functions. How's it going?
I solved the challenge exercise by converting the numbers into binary and timesing it by the variable itself.
Oh, hang on a second. Hey, how's it going?
Do you know if there's one give for an assignment, would it only mark the most recent submission?
Yes. Yeah. If you do submit something by mistake, and it's like, you know that the latest submission was a big mess, and you wanted the previous submission to be marked, you can always let us know. So your tutors are going to be the ones marking it. So you can let them know, you go, look, I've got a problem. I submitted later, and I know that the one I submitted later, I added errors to it, and I want you to mark the previous one. You can say that to us if you want to, yeah. So if you think there's a problem, you can do that, yeah.
And with like auto test and the style checker, can we do that for the assignments?
Yes, there are auto tests as well. So,
cool.
and you will be wanting to do that because the assignment is like, it's like 5 lab exercises chained together. So you kind of want to do them piece by piece. I'll talk about that in the live stream, actually. I'll talk about how we should approach it. Yeah,
Okay,
yeah,
thank
cool.
you.
No worries. Yeah. Hey, how's it going?
With
Yep.
the if statements here,
Mm.
you see how the bracket, the curly bracket here,
Yeah.
it goes there, and then it's the else if.
Yeah.
Like, I don't understand. Like, you see how with the function, the if main thing here, it goes at the bottom, and then all the stuff included. I don't understand why this one is like, it doesn't include the else if and the else. It ends there, and then you have to go
Right. So the curly brackets say what runs in that if statement.
Yeah.
The else chains on after the if statement. So
The computer knows to.
it has to be after the brackets
Yeah.
because it's part of the code that's outside the curly brackets.
Yeah.
So inside the curly brackets is what runs if that's true.
Yeah.
The else runs if that's false, right? So it has to be outside.
What if I do that? Does that work?
It'll still work, yeah. So interesting thing about C is that C ignores spaces. So note how, like, if we put lots of spaces between our things or not, it'll still run it. Yeah, so it will ignore that space. Yeah.
Okay, so is it just that the if statement knows to detect an else if?
Yeah. If there's an else after the if statement finishes, it'll see that and it'll link them together.
Like, how does the computer know? Like, I know it doesn't know, but like, how does it understand metaphorically?
So, the interesting thing about this is it's nearly the computer, but it's also a human.
Yeah.
So the compiler is written by a human.
Yeah.
So we know that we agree that this is the convention of the layout for if-else, and so it knows how to work with us if-else because we wrote that into the compiler. I say we, I didn't, but the people writing the compilers wrote that into the compiler to say that when we code, we're expecting it to be in this layout, so we should be able to compile that layout.
How do compilers work?
Compilers, it's a whole massive field, but what they do is they read your code and they translate it, in a sense, into machine code, which is direct instructions for the computer. And so it's going to read this chunk of code and go, okay, the if does this, and then if the if happens, this happens. And then it goes to the end of the if, and it reads the next line. If the next line happens to be an else, it connects it up. Yeah, that kind of thing. I mean, I don't know that much. I've never written a compiler myself, but I'm pretty sure that's the way that they work, yeah. Cool, no worries. Alrighty, let's get going again. Can everyone find your seats? Okay, so the first half of this lecture was a lot of how you're going to write your own code in order to make it understandable. Something that we might want to think about is how to actually check whether something's understandable. So when we write code to see whether it works or not, when we're writing our while loops to, I can't remember what exactly is in all the labs this week, but one of the lab questions is like count between a number and another number. That's either in the lab or the tute. I can't remember which one. So go from one number to another number using a while loop. If we want to test whether that works or not, we just run it. We run it and we see if the computer does exactly what we expected it to do. And if it works, it works. But if we don't have that, we need to think about how do we verify whether a human can understand our code or not. And one of the best ways to do that, obviously, is to bring a human to look at your code, or a few humans, and see whether they understand it. We had a good test here today because I brought code that I was pretty sure that no one would understand. And I did appreciate the amount of sort of ridicule when you saw that code. You're just like, what do you even think is going on here? There's no way we can read that, right? So, I was going to talk about the weekly tests. I'm going to finish my segue into code reviews, and I'll go back and talk about that. I just forget that I throw slides in there for other information. So, one way that we can do that is a thing called a code review. A code review is a way for us to read other people's code or have people read our code and just have a human discussion about what that code means to us. So this can be a matter of how are we going to do problem solving on the code, or is this code actually readable to us or not? In your tutorials this week, you're actually going to do a code review. I'm only going to talk about them today. And you're going to get to see what it's like to sort of poke at someone's code and decide whether or not it makes sense to you, or whether you might do things differently, and how much you can learn from different people and the way that they write their code. I'm going to hop back to this previous slide before I go too deep into this, though, because I want to talk about these weekly tests. This week is the first time that these weekly tests are going to appear. The course has a kind of a narrative structure. So I don't know if you can tell I worked in theatre at one point in my life. So the lecture is where we introduce something. So the lecture, I will tell you a topic to begin with, and that says, okay, this is the thing we're about to work on. And then we have a week, and then the next week is when your tutorial and your lab happens, and the tutorial will go back over these topics, look at some of the details in them, and then the lab says, all right, now that you've seen it in the lecture, maybe had a chance to talk to your tutor in the tutorial about it, some worked examples, now try to build it yourself. So we go through that kind of sequence into the lecture, the tute, the lab, and then the thing after that is the weekly test. And the weekly test is a little bit of how well did this work for you? Did the learning process stick or not? So the weekly test will go a week after the content, and it will ask you to use that content, which means this first weekly test is actually roughly the week 1 lecture, week 2 tutorial and lab is then being tested. So you'll find that there's not going to be any looping in the first weekly test, but the second weekly test will have looping. So it's a good thing to sort of space out your learning over 3 weeks like that to see whether you remember things that well. So the weekly test, if you want to, can be done in 1 hour. And we've got a little timer on the actual website there where you can click go and it'll actually count down 1 hour for you. I suggest that this is the best way to do them. So run it under exam conditions. This is our way of saying if you do this under exam conditions, then when we hit you with an actual exam, this won't be difficult for you. So this is actually a psychological thing. And you do this in a very gentle way with people who have had certain traumas and things that's phobias and other stuff like that, where you try to introduce people to the situation that is difficult for them in a way that's a little bit safer. And you do it a little bit, and you try to do this sort of repeated exposure in a safe way to the point where they can then approach that dangerous situation with less of a kind of psychological block happening when they're actually in there. So the weekly tests are a way of easing you into the exam. So when we do the exam, you're locked into, well, you're not locked in. You can leave if you really want to, but you're in one of our computer labs and you're not allowed to use Google, you're not allowed to talk to anyone, you're not allowed to discuss anything, and you're expected to perform under those conditions. It's a little bit cruel, but there's not really any other way to examine a whole course and make sure we understand that everyone is being assessed fairly. These weekly tests are your way of getting familiar with that kind of environment before you get put in it. So it's not a shock to your system the first time you do the exam. You can say, no, I've gone an hour without an internet connection previously. Well, you might still be on the internet because you're using VLab or something, but you're not necessarily looking up the answers as you're doing it. So you don't have your lecture slides available to you. You don't have Google available to you. You don't have reference websites or anything. All you've got is just you and the code and see whether you can do it or not. So the more you do it like this, the better practice you're going to get so that you can handle these situations. I should also point out that these are pretty similar to the kinds of things you're probably going to get in job interviews as well. I mean, slightly different because in a job interview, you'll have a person there with you and you'll be able to bounce ideas off someone. But again, it's going to be you and the code and not much else you can work with. So the rules are in the test itself. So when you open it, you can see them and they'll say, okay, 1 hour, no references, no looking things up. The only thing you have if you want to is we have a reference sheet there, which is the same thing we're going to give you in the exam, which has some of the things that we would commonly Google while we're writing C code, which is what are the inputs and outputs of scanf, for example, like how does this thing work and stuff, just basic reference like that, but not how do I structure a while loop, the things that you're expected to know and will be tested on. So 1 hour is a good amount of time to put into these. At the end of the hour, when this finishes, you can look at how successful you were with that particular weekly test. And if you feel like you're not as successful as you want to be, you can go back and you can study things further. Roughly, if you get one question right, we're probably looking at a pass for the course. If you get 2 questions right, we're somewhere around a credit to a distinction. If you can get all 3 questions right within an hour, then you're kind of smooth sailing and you don't really have to go back over that particular week's material. So it's a good way for you to practice for the exam as well as know exactly where you're sitting at this point in time and know what you want to go back and study. Question there. The question is, do the weekly tests have auto tests? They do. So you will be able to get some verification of whether your code is working or not. There's marks for the weekly test as well. So if after the hour you weren't able to complete everything, but you want to go back and look things up and complete it, you can if you want to. And so if you want to, you can go back, look up resources, answer the questions, potentially get full marks in everything. Bear in mind, though, that if you spend all your time doing that, weekly test still is only worth 5% of the whole course. It's not something that I necessarily recommend you have to put hours and hours and hours into. I don't think that's entirely necessary. It's more there for you to get feedback on how you're going. Because even if you only attempt the first question, you don't even go any further than that, you can still get half marks for the entire weekly test. I think that's the way we're marking it. I've got a question over there.
Yeah. Is the week for the coding test, is the auto test the same as the submission of the test, or are they two distinct things?
Oh, that's a good question. So the question was for the weekly test, and we could broaden this question to the entire course, is the auto test the same as the marking test for it? And no, they are never the same in anything that we do. So if they were the same, then you could write a program that says, if input equals 30, output equals the numbers that are correct for the input 30, right? And so you just simply parrot the correct output for the input, and you'll pass all the auto tests like that. So if you should try this in your labs. So some of the lab questions will be like, the auto test is expecting this result. So write a program that just says, if the input is this, the output is this. If the input is this, the output is this. Don't submit it though, because you will get 0 marks for that, unless you're really lucky. So writing code that specifically covers the auto tests, so it just checks if this, reply this, if this, reply this. That's not going to get you any marks, but if you do code that says, all right, we want you to loop through these things and give this kind of result, then you'll pass the test. You'll pass the marking tests if you pass the auto tests.
Also,
yeah.
It's in the weekly coding test as well, right?
Yes, the weekly tests are the same, that they've got auto tests as well, but we're never going to mark you with exactly the same tests that we auto tested on, because otherwise, you can write really dodgy code that just passes auto tests and doesn't actually do the thing we asked you to do. Yeah. Okay, so the weekly tests, the first one we'll be releasing on Thursday, and you'll get 1 week to do it. So I just want to remind everyone, because we usually talk about a lot of the stuff, like the labs and stuff like that, on the forums and in tutorials and things like that. If you want to talk to someone about the weekly tests, you can ask your tutor about it. But please don't post anything on the forums about it, because it's kind of like spoilers, right? So we give everyone 1 week to watch. Actually, no, there isn't even a big series out now or anything that people are watching. But like the big one was The Mandalorian for me, because I had some friends that spoiled it for me, and that was really annoying. So we want to give people at least 1 week to work on it themselves before we start spoiling it. So we're not going to discuss the weekly tests in the forums until the week after. Also, until after the due date, basically. And then we're free to discuss it. But until then, we want to give everyone the chance to have their 1 hour with it and have it fresh. Okay, so going on to, I was talking about code reviews. And we were talking about auto tests as well. So the auto tests that we are using can definitely test whether your program is spitting out the correct outputs. So whether it's reading in the right things and spitting out the right things. But we can't test how easy it is for someone else to make changes to our code. We're not testing how well our problem solving has worked in the code. Has our solution been something that worked nicely, or did we, instead of looping 10 times, write the same code 10 times and then just expect it to work again and again and again? You know, there's better things we can do. So this is a little bit like the process of proofreading if we were writing a report or something like that. We get someone else to read it, and they can tell us which bits they do and don't understand. So code is even more so like that, because code is, I mean, it's a little bit written for humans to understand, but it's very, very easy to write code so that humans have no idea about how to understand it, as we saw earlier today. So we can actually look at each other's code. We can learn a lot from this. So if you're writing the code, having someone else look at your code is really nice, because they can point out anything that feels weird about it. We can figure out how easy it is for someone else to read our code if we just let someone else read it, and they can point out to us what is and isn't working. The other thing that's really, really interesting is we can discuss different ways to solve the same problem. So you may notice that we have kind of been doing this to you subtly in your labs up until this point as it is, because we've been putting you with lab partners the whole time. as we know that we're not really programming in a vacuum, we're not programming solo once you get out into the world. So we want to make sure that you know how to code with other people, and that means you're discussing things with people as you're going, which means you're thinking about different ways to solve problems. Someone else is always reading your code. Well, that's if you're working, hopefully everyone's working correctly with your lab partners, where there's always two of you looking at the same code. You can get different ideas about how that code ought to work or not. So, a couple of ways, I was just sort of segueing into this. We can do pair programming, and that's actually very good for this idea of code review. It's sort of an active review where you're always looking at each other's code, you're always looking at how people are doing things, you're always discussing how you're going to work on things. And so this means every step of the way, you're sort of reviewing the other person's code as it goes along. The other thing that we do, and this happens much more in a professional situation, although actually we do heaps of pair programming professionally as well, but in a professional situation, we'll often stop, grab our code, sit down with a few people and say, okay, let's have a look at this code and see how it works. This is usually done in groups of sort of 3 or 4. I have previously done a code review in the lecture, but it doesn't quite work as well because we get this sort of, you get this effect of the more people that are looking at something, the less likely people are to talk about it. It's really funny. It's like when you've got a whole room of people looking at it, people don't often point out simple things because they just think, oh, everyone's going to pick up on that anyway. So the best number for a code review is actually around 3 or 4 people. You're going to be doing your tutes with slightly more than 3 or 4, but at least that's a way to sort of learn how it works. So when we do a formal code review, it can be sometimes one person's code up on the projector, them doing a very brief, okay, this is what I intended this thing to do, and then everyone bouncing ideas back and forth about maybe how they would have done it, or I don't understand this particular part of it, can you explain it, and things like that. We can get a lot of information out of it like that. So the first thing is pair programming. I discovered this very, very early on by complete accident. This was... Anyone here remember Command and Conquer? It's a, oh yeah, one person. It's a super, oh yeah, there's another person. It's a super, super old computer game. So this is just me showing my age here. Actually quite specifically showing my age. So we were playing this in the age of dial-up modems. And we had groups of us that wanted to play the game, but obviously you can only call one person at a time. So myself and a friend would be at my place, and we would call another friend at their house, and this was 2 brothers at the other end. And so we had 2 computers linked up together and 4 people. So what we ended up doing was one person was on the keyboard and one person was just sitting beside them, yelling out instructions at them. And you may find that this works remarkably well. This did work really well for us, and it works remarkably well for programming. Because what happens is the person on the keyboard is worried about what we would call the micro. Is this still a thing, having Uber Micro in gaming? Some people are nodding. Okay, some people are gamers. So everyone's really embarrassed about being gamers. But Uber Micro used to be how many times you could click on the game. So how much you can move your little units around and stuff. And then the person over the shoulder was thinking of macro. So they were thinking about the longer scale thing. They were saying, okay, go back to the base. We need to build this now. We need to be teching up in this particular direction now before we get into another fight, that kind of thing. Okay, I don't know if this example works for everyone, but it works for me. Okay, so what works for this is the same way that I was talking about trying to separate your problem solving from wrangling C itself. So wrangling C itself is an exercise of how do I translate my thoughts into C code. And that's really a matter of, okay, the if statement needs these brackets here, I need my semicolons here, I need this structure here, it's got to be less than this one. Is it less than that one, or is it less than or equal to this one? You know, you're doing all of that low-level thinking. And while you're doing that low-level thinking, it's hard to think about the bigger problem. The bigger problem is, okay, what was the initial question we're supposed to answer? What kind of code do we need to answer that question? So you can have one person thinking about that while the other person's translating it into C. It turns out that in a genuine industrial perspective of making code, this is more efficient than having 2 people write separate code. So you can have two people only produce one file. It's still faster than if they worked on separate projects. And I've seen this in action. It works really well. So you're discussing as you go. Your code's constantly under review because someone's looking over your shoulder saying, hey, we could change that. We could do that differently. So I suggest this is a really cool way that you can do your labs where you can put one person on the keyboard and the other person just looking over their shoulder. Your tutors can help you with a command to copy the code between you because we fully expect lab partners to submit exactly the same code because we expect that you worked on it together. So try this. Flip back and forth as well, so you have some time on the keyboard and some time in the thinking role, and you can go back and forth. You'll find that you can get a lot out of the code like this. You'll have more active discussions about how you're solving problems. You may also find you finish your labs faster and get to do challenges. Don't do the challenges like this. Challenges are solo, but hopefully this will help a bit. If we're going to do something like a more formal code review, what we will do is we will have, I said here a finished piece of code, but it's not necessarily a finished piece of code. It can just be a piece of code. And sometimes it's like, this code isn't working, I'm not sure why. Can we review this? Can I get a few people looking at this and can we see what's going on? In your tutorials, there will be an opportunity over the next 6 weeks for you to actually volunteer, you and a partner to volunteer some of your lab code to be code reviewed. So some of these are really interesting. If you show lab code where you say, we weren't really sure about the solution to this, it was a little bit weird, we didn't quite get what we wanted out of this lab exercise, what can we do? And then everyone else can talk to you about how they did it, and you can share ideas. One thing that we want to remember that what we're doing with a code review, because it can be really, really daunting to put your code up on a screen and have 20 people pick at it. So this is especially good to remember when you're reviewing someone else's code, is we are not looking to try to crucify someone for their little mistakes and stuff like that, right? So that's not what we're doing in a code review. We're actually trying to help people with things. So we're judging the code, we're not judging the coder. Somebody isn't a horrible person because they forgot a semicolon. Maybe, no, I kid. So we don't want to approach it in a way where we're giving them marks or something. It's judgment or it's punitive or something like that. What we want to do is be helping each other with things. Some of the things that's most important when you're reviewing, and it's a really hard thing to say when you're in a room full of people, but one of the hardest things to say is actually one of the best things to say in a code review is to say, I don't understand what that thing does. So a lot of the time we're going to look at a piece of code. I mean, we could put up that bad code again, and I could say 90% of the room would be like, I don't understand that whole thing, because it's a huge mess. I don't understand what's going on. It's really, really good to be able to say in a review, can you explain that piece there? And that gives some really good feedback to the person who wrote the code, because then they can say, that's where there should be a comment. Because if someone needs to ask me for advice on what something is, then I'm missing some information. The other things which could be really interesting is if you had a different solution for the same problem. You can discuss the different solutions to the same problem. You can discuss the pros and cons of every solution to the same problem. As you may have noticed already, C has many, many different ways of solving a problem. You can't say there's only one way to get a particular result in a programming language like C. It's a very open language. It's a very powerful language, so it can do many, many different things, which means there's going to be potentially 700 different ways of completing every lab exercise. I mean, they're not going to be that different, but they could potentially be very different, and that doesn't make any of them correct or incorrect. It's just different ways of approaching things. Seeing other people's approaches is super valuable. You can get a lot out of that. Okay, what not to do in a code review? You did this wrong. Your code is bad. Oh, here we go. I'm just going to pull out all the mistakes in your code, and this is what's wrong. So we're not trying to judge people. We're trying to help. And again, in the same perspective, just remember it is hard to put your stuff up for review. If you want to know how hard it is to put your code up in front of the class, then you can volunteer for the first one, which is next week. You can go to your tutor this week and say, I'm up for the code review. I think it would be interesting to have my code up there and to see other people's ideas about your code. You can learn a lot from that. Yeah, I think I've covered most of this stuff here. Yeah, there isn't any single way to solve a problem, which means there are multiple correct ways to solve a problem. The value also is the more different ways you see to solve a problem, the more techniques you learn. So some of the best stuff is learned in code reviews where you're doing something a particular way. Someone else comes into the code review and goes, oh, I did it this way. And you compare the code between them, and then you say, oh, I'm not necessarily going to change the code I did here, but seeing the way that you solved that gives me an idea for how I can solve other problems. And suddenly you've got another tool in your little virtual toolbox of programming ideas that you carry around with you all the time. All right. So this week's tutorial, as I said before, I mean, some of you already know this. Everyone who had a Monday tute will know that the tutor will be doing a demo code review in the tutorial. They will probably get you to participate in this as well, because I think you don't need that much knowledge in advance to be able to partake in a code review. You actually all have partaken a little bit in a code review earlier today when I showed you that code and we tried to think, what are the bits we don't understand about it? What are the bits we can improve so we can get better understanding? So I say it's a good idea to do stuff like this with your lab work. If you've got a group of friends you study together outside of the class and stuff, you could do that. You could get people to look at your code and see how well each of you understands it. Please don't do it with your assignments, though. That's a level of collaboration that we don't want happening, because if you've solved all the problems in your assignment and then you get someone to code review it, suddenly they don't get a chance to actually think about how to solve the assignment. All right. So I wasn't going to spend the whole day without doing a little bit of technical. Oh, we had a question before I move on. Yep. The question was, can we look at other people's challenge code? I would say don't, because it ruins a lot of the challenges. So who's had their tutorial so far this week? So all of you have seen the challenge for this week, and one of the particular challenges for this week is super thinky. That's a technical term. You've got to bend your mind around this thing to figure out how you're going to do it. And it was intentionally put in there. It's a challenge, so it's not something you have to do, but it was intentionally put in there to get you thinking differently about programming than about doing things just the right way. You kind of have to do things, there is no wrong way, but you kind of have to do things the wrong way, and you have to twist your mind around doing things a different way. If you show someone else your solution to this, then that breaks the one golden rule that I say, that we don't want to take people's chance for education away from them. It will take their chance away. It's like you've totally spoiled it if you show someone the solution to this. So heaps of the challenge problems I think are not good for lab, for code reviews because of that. But if you've all finished it and you want to talk about it the week after, yeah, go for it. Because if everyone's already done it, so if you know, you can check with everyone. It's like, oh, have you already completed it? We've all completed it. Okay, we can discuss it now. Because otherwise it can really ruin it for people. Because I could, in one sentence, I could ruin this whole thing and give it away. Which we had a discussion about this in the break, and I had to mute the recording so that whoever's watching the recording doesn't get it given away for them. Yeah. So I think the lab work is the best place to do code reviews if you want to do informal code reviews between you. And generally, because you're working in pairs, you're sort of going to be doing code reviews as you're running these things. Okay, so I'm going to move on to a little bit of some technical programming. I'm going to add another tool to our little toolbox today called functions. The interesting thing about functions is that you can't do C without functions, and you've been using them already. So we didn't explicitly say what functions were, but they've been in everything that we've been doing. So main is a function. You may have heard I've been calling it the main function the whole time in a little sort of precursor to me explaining fully what functions are. So we haven't written our own functions, but we've been using main, and things that we've actually been using functions that other people have written as well from the standard input-output library. So we've been using printf and scanf. So let me explain what a function is. A function is a chunk of code. It's a chunk of code that is between the curly brackets, and it will run that code. I'll have to go into more detail about exactly how it does this. Every function has an input and an output. So you'll note that in our main functions, oh, this is going to be a bit hellish because it's still just a function here. It has int main void. So it's got stuff in here and stuff that sort of looks reasonably familiar, at least that int. I did get questions about this in the first or second week. People saying, what does this int main void mean? I had to say, okay, wait for it. I will tell you exactly what this means later. But a function is set up with an input and an output. And we'll notice that, this is a really bad one because I wrote this with bad style on purpose, so it doesn't have the return 0 at the bottom. If I had the return 0, what I was actually doing there was giving back an integer. So the function itself has a type in the same way that a variable has a type. And these types are things like the ints and the doubles that we've seen that are variable types. This is what our function gives back. Let me go back to my slides because I've got this laid out in a better way for learning. So we have inputs and outputs, and we can call a function. So this is the terminology we're going to use as we're using functions, as we're going to call a function. And what calling a function does is it says to my computer, all right, go to that function now, go into the curly brackets, and execute all of the lines of the code line by line. So our main function does that automatically. The main function always is the first thing that runs in a C program, and so we go into the curly brackets inside our main function, and then we execute the main function line by line. If we have another function, we get this kind of effect happening, where the main function could call another function. So it could say, hey, can you run this other function? This is what happens when we say printf. When we write printf in our code, that is us calling the function printf. When that happens, we jump out from the sequence. So we're no longer going line by line. If we say printf, we're jumping to the printf code. The printf code is somewhere else. So it's somewhere else in our computer, the instructions for what to do when printf happens. We pass some information to printf, and that information is what we put inside the quotes. So we can say printf, please input something, something. You know, that information gets passed to that function. That function runs with that. And printf, for example, one of the things it does is it will then write those letters that we typed into the terminal. So part of the code that it has accesses the terminal and says, okay, this information is going out to the terminal. When it's finished, it will then go back to the main function, and the main function will continue doing its line-by-line thing from wherever the printf had been. So when we see it and when we use it like it's just a single line of code that does something. But printf itself is, I actually don't know. I haven't looked at it. But I'm going to assume it's, 50 lines of code somewhere else. I don't know, 50 is a lot, but maybe it's got other things happening. So it's another chunk of code somewhere that runs, and when it finishes running, we come back to our function and we keep going. So functions are a way for us to not just be stuck within this single flow of line by line. We can jump out to another entirely separate piece of code, run that, and then jump back when we're finished. The way that we write... Ooh. Let me just fix that. So if we're going to write a function, the first line of the function, so this is us creating a function. The first line of the function tells us a lot of information about what it is. We declared variables before by saying, okay, an integer is a variable, and then we give it a name. We might give it a value. A function is similar in that we will give it a type first. And so this is actually what the function is going to output. And by output, I mean that the line where you call the function, so I call something like this add function, wherever I put this add function, when it finishes running, it's basically going to transform itself into an integer. So wherever I put this add line in my code, it's going to turn into an integer. A function has a name, and that's the second thing here. This one's called add. You can name your functions whatever you want to, and we had talked earlier today about trying to make names make sense to us. So try to make your function names make sense. My advice for functions and variable names is variable names are nouns, so they're object words. They're things that sort of have a concrete, I don't know, I'm trying to think of how to explain this, like a substance in a sense. So it's like they're a number or they're a name or something like that. Whereas we like to call functions verbs. Verbs are doing words, so this does this. Or if we run this function, this kind of thing happens. And so if we think about it that way, we're more likely to get the right kind of names for our functions, and we'll be able to tell our functions and our variables apart when we see them in our code, because this thing obviously has an action associated with it, whereas the variable obviously has a quantity or a value idea attached to it. Okay. The next thing in the brackets here, so you'll note that this kind of layout is really similar to what we would have in something like an if statement or a while loop, where we've got the normal brackets and then the curly brackets. Instead of the normal brackets here being a question, these normal brackets are actually what information is going to go into the function. So we call these the inputs of the function. We also call these sort of parameters of the function. So you'll hear them given different names depending on who's doing it, and also depending on which programming language, because lots of programming languages have functions. Some programming languages don't even call them functions, they call them methods. So there's going to be, just because lots of different programming languages were developed at similar times, there's different names for everything. We're usually going to call them inputs or parameters, or just to double up, sometimes we'll call them input parameters. So if we have this add with these two integers, it means that when we call this function, so when we use add, we're expecting two numbers to come in the same way that if you use printf and you don't put anything in there, your compiler will probably say there's something wrong with this printf. We're expecting some input, and printf expects a string of input, which is like a sequence of characters with the double quotes. Question there.
So when we use the main void, what is the void?
Good question. Hang on, is that my next slide? It's here somewhere. There. Okay, I'm going to skip to this now because you asked it, and we'll go back afterwards. So there's a keyword called void as well. Oh, wait, no, that's a different one. That's different. We'll talk about that later. I'll answer your question, and then we'll go into that stuff. So void is a C keyword. So the question was int main void. What does the void mean? The void is a specific thing for our int main that says no information is going into this program when it starts. We do actually have ways of giving information to our program when it starts. We're going to talk about that later. But the int main void specifically says there are no inputs to this function. We can actually make functions by just having these brackets empty here and say, right, nothing's going in. So when I say here in the slide 0 or more inputs, the int main void has 0 inputs. So I'm saying that it can run without us giving it any information. All right, then we have the curly brackets, and the curly brackets we've seen. So we've seen these in our main functions. We've seen these every time we're going to separate code into a specific section. The function will run from the opening bracket to the closing bracket. We also have return in here. Return is an important keyword in C. So previously when I said return was just going to end our program, now you know a little bit more about the subtlety of what it's doing. Return is not ending our program. I mean, it is, as a side effect, it is ending our program. But what return is actually doing is it is finishing the function that it is in and giving back the output for that function. If that function happens to be the main, then yes, the entire program finishes. But if it happens to be another function that we're using, then return can say, this function's finished, now give back the answer. So a lot of our functions are going to have a particular answer they try to give back to the rest of the program. So return will give that output back, and it will also stop the function running. So here's an example, some code of a function being used. So there's that add function. this piece of code assumes that the computer already knows the add function. So it's already seen that add function somewhere, and it's now using it. So this should look reasonably familiar, because this is the kind of thing that we were doing with printf and scanf, right? So with printf and scanf, if we want to, there's ways for us to put variables into that, you know? And it's a list of things with commas here. So this is calling a function. So if I already know what add is, I can call the add function here. And if we saw it here, the add function took in 2 integers, which means I'm putting 2 things in here. These happen to be integer variables, so that's fine. It will take the values that I've stored in those 2 variables, 4 and 6, and we'll add them together. So we're expecting, after this runs, the integer total will equal 10, because we know that add here is going to add A and B. This is a really, really trivial function, because like it would be easier just to write A plus B, but I just wanted to show you the structure of it. So now we have a way of separating our code into another piece and being able to say, okay, every time I want to run that piece of code, I'm going to say, this is the name of that piece of code that I want to run. It's called add, and this is the information it needs to be able to do things. So I pass in that information. And add is an integer function. So it being an integer function means basically this whole section here where I called the function will run, and it's like that whole section there then just transforms into an integer. And in this case, it'll be adding up those 2 numbers, 4 and 6. So this entire chunk here of add first number, second number, when we run it, it will go off, do its calculation, basically transform itself into a 10, and then we can act as if this was the 10 here, so total equals 10. The value of the function will be put into this variable. So now we have a way of basically having code that's separate. You know, we can say, this thing does this, and it's off to the side. We don't have to look that carefully at what it does, because we're just going to trust it to do what it does. And what we've done in our code here is we've actually replaced it with an English word and some stuff. So we can have some really, really long, complicated functions, but we've packaged them off to the side, and we just use them by name, and it's easier for us to sort of read and look at our code like that. Also easier for us to repeat use of things, because we know it's off there and it works. Question over there.
In your code, where do you actually place that function?
Good question. Is that my next thing? I am definitely getting into that. So we'll go into that now. I have a little segue into that, so I'm going to do that now, and hopefully your question will be answered in the next couple of minutes. Okay. So, good question. How does our compiler know the add function? Where do we put this add function so our compiler can understand where it is? So, remember that our code is running line by line, top to bottom. Our compiler also reads our code line by line, top to bottom. Which means if you're trying to work with, say, variables, we've seen this already, you can't work with a variable unless you've already declared the variable. So you can't give a value to a variable if you haven't said to your computer previously, hello, can I have my 32 bits of memory somewhere reserved under this variable name so that I can write to that memory, I can change its value, that kind of thing. So if I have this int number here, and I have this int total equals number plus other number, this won't work because it doesn't know what other number is. Even if other number is declared, if it's declared below where it's used, my computer doesn't know about it yet, because it's read it line by line, and it says, no, other number doesn't exist. Even if you're going to make it later, it doesn't matter. I can't use it up here. So functions are actually going to do a similar thing, where in order to use a function, we have to know that it exists. Functions are more complicated than variables in that we don't actually have to completely know what the function is. We only need to know that it exists and how to use it. We don't actually need to know all the code for it. So this kind of layout is how we use functions most of the time when we're in a single code file. We are going to get into using multiple files for a program. And very often when we're using multiple files, the function's in another file. Very, very good example of this is the standard input-output library, stdio.h. That's a separate file. So every compiler has access to the file standard input-output.h, and that's what the hash include does. I'll get into that later. We're going to explain that in detail. But that function is somewhere else, and because that include is at the top of our program, we know all of the functions that are in that file. So when we want to use a file somewhere in our main, before our main runs, we have to have declared that function. So up here, I can say there is a function called add. It gives me back an integer, and it takes in 2 integers. The function is actually defined, as in all of the instructions that it does, after the main. So before the main, we say, okay, these are all the functions that we might be using. So this can actually be quite lengthy. When we get into the second assignment, the first assignment, you can use functions if you want. We're gonna try to get you to use a lot of functions. The second assignment will be completely, I was about to say non-functional without functions. Yeah, I got one laugh. Yeah, so the second assignment, you'll have to use functions. The first assignment, you can use them a little. We are going to give you some marks if you do use them. But the second assignment is going to be all based on this. So there's going to be a big list of functions at the top, and then all of the functions that we've created down at the bottom there. I am going to do a bit of demo in this tomorrow, but I didn't have time today to squeeze in a code demo, so we will definitely look at this. So what we need is, when we're reading top to bottom, we need to know that the function exists, and then somewhere else we can say, okay, here's where the code is for the function. Is that a good enough answer to the question, I think? Cool. So void functions, which I was going to skip to a second ago, but slightly different. We can have functions that don't give us anything back. So we can have functions that say, I want you to run something, and I am interested in something happening and having some side effects of that happen, but I don't actually need you to give the program back any information. And this function will then be of type void. And it's interesting because, actually, I don't even know if printf is a void function or not. But either way, we can do a void version of this add function that is still going to add these values together. But instead of giving back this value, so we're not actually returning it. Actually, I'm not even sure if we need the return here at all. But instead of giving back the value a plus b, we could print it out instead. And so the value is of some use to us, but it's basically being given to the human that's running the program instead of being given back to the program itself. And this add function then just has no output. So no information goes back to the program. When we run the add as one of the lines of our code, it does not transform into an integer in the same way that an integer function did. It just disappears. So it does what it needs to do and it disappears. The most common void functions that we're going to use are the things that just spit out some information to our user, and we don't need that information ourselves. So there's a void function, meaning we don't get any information back in the program. Okay. Oh, this is like the first time ever that I've finished before the recording stopped. So quick recap of what we did today. We're looking at code style. I should also point out with the functions, usually I would do a code demo immediately afterwards, but what I'm going to do tomorrow is I'm going to introduce arrays, and then we're going to do code demos there. So we looked at code style. We did a mini sort of code review, but that was more of an error checking thing. We're thinking about what it means to read other people's code and learn from it and have your code read. And also we're looking now at functions and separating code. So I'll see everyone tomorrow at 11 a.m. and we'll do more coding tomorrow than we did today.
How are you?
Not too bad. How's things?
Oh, good lecture. Quickly, I have a void function here, but I still get, when you say it doesn't return any output, do you mean?
Yeah.
I get 4 plus 5 is 9. Is it supposed to be, when that output, you mean a print?
Different kinds of output. A print statement is something that we can think of as output to the human, but it is not output from a function. So output from a function is information that goes back to other parts of the program.
Oh, okay,
Right?
okay, that
So
makes
the
sense.
printf is output to a human that's not necessarily information that goes to the program.
Oh, you mean the int main? Yeah, yeah.
Yeah, yeah.
Oh, okay,
Yeah.
yeah.
Yeah. So when you do a function that's an int function, that's the idea of
Yeah,
it
yeah.
transforming into its type.
Yes.
So when you go back to the line that it was called, where it actually calls, it transforms into the type
Yeah, yeah,
that
yeah.
it was, right? So that's why I like to explain it like that, because I think that makes it a little bit easier to understand.
Yeah.
The function type is what it transforms into.
Yes.
Yeah.
Alright, thanks for that.
Cool, no worries. Hey, how's it going?
Oh, yeah, alright. Last week I wasn't able to do the challenge exercises,
Yeah.
so I didn't submit them. How would that affect my marks? I think I got everything else right.
It won't.
Okay,
So if you get full marks in the lab and don't do the challenges, you still get full marks in the lab.
okay, so challenges are just like bonus points.
Yeah.